Okay, so this is variation. I have some material which we can all refer to. It says that in maths, we usually deal with two types of quantities: variable quantities, those that change values under different conditions, and then constants that do not change no matter the condition. Before I take the next sentence, let's look at what we call variable quantities, especially in terms of examples. We are saying that these are things that can take changing values under different situations. So what are they? Can any of you give an example of what we call a variable quantity? Okay, so let me call on Cassandra. Cassandra, can you give us one example of a variable quantity?
Akufi.
Mm-hmm.
You said that variable quantity changes under different situations.
Yes.
As in life, the example.
Yes, it's the example I'm looking for.
Okay, so the behavior of a person is determined by the environment the person.
Yes, behavior, but you see, these ones, even though we understand the change, it will be difficult to quantify the change. We are looking at things that we can actually work out if any change has occurred and what the quantum of changes is. You get it? Let's look at
Can I
temperature in our
say
room.
the price of something?
Come again.
Can
Cassandra,
I say price of something?
yes, cost of items. Cost of items for a particular item, you can be sure that it will not remain the same throughout time. Bread, for example, these days I know bread is appreciating in value. Good. Okay, so can you give us another quantity that we know can change under different conditions?
Sir. Okay. Apart from talking about something edible.
No, not necessarily in things that we eat, but what is it that we can be sure that, oh, today can have this value, the next moment it can become this.
Okay. Say a tree.
A tree.
Yeah.
What about the tree?
Today, as it's growing, maybe it might be bearing fruits. Maybe the following day. Yeah.
I like your example, but the direction is going is not too good. See, he said a tree. What about the tree? What is it about the tree that we can see changing, and for that matter, we can measure?
Okay, say its height.
Yes.
Yeah.
Its height. You get it, especially if it's a tender tree. Its height will change. So height of trees.
Okay.
Is that okay? Okay, now that you have given one example, can you add one more?
Yes, sir.
Okay,
sir. Hello, sir.
Yeah, I'm here. Yes.
Okay, let's talk about the price of a phone. As
you people, you like phones. You like phones.
Maybe the people keep on increase this price.
Okay, it's all right. So price of phones, it's okay. So we know that these things will change with time. So those things that change with time, we call them variables. And as you can read from the test, those that remain the same, no matter the situation, they are called constant. Elisa, are you back? Okay, she doesn't look, it doesn't look like she's back. But Blessing, can you give us one quantity we can call constant? And as you see in the test, it says that if the value of the quantity does not change under different situations, it is called a constant. So can you give us one thing which will not change no matter the situation? Yes. Blessing, are you there? Blessing, we are waiting for you. Okay, so Elisa says she has to be excused. Blessing, we can't hear her. So it means that I'll have to be directing the questions to Augustine and Cassandra. Cassandra, can you give us one quantity we know its value will remain the same?
Mr. Kofi,
Yes.
is the mass of a body.
The
The mass of a body.
mass of an object. Oh, Cassandra, will your mass remain the same? When you eat and eat and eat and eat. Today, if you are weighing 50 kilos, the next 2 days it will be 120 kilos. Maybe elephant. So the mass cannot remain the same. Come again.
Okay.
Come again.
Yes, please.
Mm-hmm.
Mr. Kofi, please let me think about this for something.
I should let you think about it. Augustine. Augustine. Augustine, are you there?
Yes, sir.
Yes. Can you give us one quantity that will remain constant no matter the situation?
Okay. Sir, let's talk about the number of fingers somebody has.
Good. Let's clap for him. Unless you get into trouble. But the thing is, it says no matter the condition, it should remain the same. If you don't land into trouble, you have 5 fingers, isn't it? So the number of fingers of a person, unless he is involved in an accident, will remain 5.
Yeah.
Is that okay? All right. Elisa, we are talking about what we call variable and what we call constant. We are saying that constants are those quantities whose values do not change no matter the situation. Variables are quantities whose values change under different conditions. Cassandra and Augustine have given so many examples. In fact, each one has given 20. Did you hear that?
Yes.
They didn't give 20. They have given, in fact, they struggled to give even one. But once you are back, you have brought that good spirit, so they will be able to give more. Yes, can you give us one quantity which we can call a constant?
Avogadro's number.
Avogadro's number. Okay. And then what again? What again?
That could be something thinking about. The
You are
speed of
thinking
light.
about it.
The
All right.
speed of light.
All right. All right. Let's look at this. Another constant you can think of is, you see, ratio of the circumference of a circle to its diameter, no matter the size of the circle. Are you there? Yes.
Please, I think the mass will be right because mass is different from weight.
Mass of a person.
The mass of an object.
Of a non-living.
Yes, please.
But there are objects that are non-living, especially if they absorb moisture, they will increase in mass.
So the mass is different from weight.
Yeah, yes, but let's look at something that can absorb moisture. All right.
Yes, please.
Any object like piece of wood, when it is dry, we know it will have mass, it will have weight. If the same piece of wood lies in the open, exposed to this harsh weather conditions, there are instances where it will absorb a lot of moisture, and the mass of that same piece will change.
Okay.
But what I was talking about is ratio of the circumference of a circle to its diameter. If you divide the circumference of a circle by the diameter, you must get a constant ratio. And what is that constant ratio? Oh, if you divide divide the circumference of a circle by the diameter, what do you get? Okay, let's do this. We should be able to get the answer. What's the expression for circumference of a circle, Elisa?
2 pi r.
We've got
Say
2
say
pi
get
r.
pi.
And then what is the diameter of a circle?
Say
Yes, I'm coming. What is the diameter of a circle? It's going to be 2r. So if you divide 2 pi r by r, what do you get? You get pi. And any circle that you can land, you can draw, you divide the circumference of a circle by the diameter, it will give you the same value. So these are the quantities we call constant quantities, okay? Those that do not change under whatever conditions, they are constant. Those that change their values under different situations, we call them variables. Good. In mathematics, relationship exists between two variables. So now we know what variables are. Quantities whose value change with time. In maths, we have relationship that connects variables. Okay, so now let's come back to this one. We know what variables are. Can you mention two variables that are connected in a way that a change in one must bring about a change in the other? Yes. Who is going to start? Who is going to start? Elisa, we now know what a variable is. We are going to point out two variables that are related such that as soon as one thing changes, the other one also changes. Hello. Guys, can you hear me?
Yes, this
Mr. Kofi.
Yes, but no one is responding. Why? I'm
Can you
saying that,
say
yes.
mass and weight?
Mass and weight is a very good example. That when the mass of an object changes, its weight will also change. So in this kind of change, it is happening because of the relationship that exists between them. Is there anyone who is also ready to give an example? Two variables that are related in such a way that one change brings about a change in the other. Yes.
Distance and time.
Distance and time. That is, if the object in motion is moving at a constant speed. Once the distance changes, the time is also going to change. All right. So we're saying a mathematical relationship exists between two or more variables. As a result, when the value of one variable changes, it causes a change in the value of the related one. Such relationship with regard to change in the value of one variable, when the values of the related variables change, is called variation. Such relationship with regard to change in the value of one variable, when the values of related variables change, is termed variation. We have different types of variations. We have the direct, we have the inverse, we have the combined, we have joint, we have partial. We are going to look at them one by one. What is the direct variation? And you can see it in the text that in variation, if the variables change proportionately, we see that in real life, even though that word proportionately may not be strictly or may not strictly apply, but we understand that the longer you travel, the more you pay. Is that correct? for a particular means of transport. If you are going to fly, the longer you fly, the more you pay. It's just that the change will not be proportionate. So where a change in one brings about a proportionate change in the other, we say that the quantities involved are in a direct variation. All right, I think this is enough of when it comes to introduction. So now let's get into business. Let's get into business. Let's take the last sentence. It says that if X is in direct variation with Y, we can write them in symbols as X proportional to Y. Okay, this is where we will start the work on variations. Saying that if X varies directly with Y, we're going to have X proportional to Y like this. Now here, we can change the proportion to an equation. And each time we change a proportion to an equation, we'll have to find a constant multiple, or we call it the constant of variation. So here, changing the proportion to an equation, we're going to write X equal to Ky, and then we'll write that where K is the constant of variation, where K is the constant of variation. All right, how do we handle problems in direct variation? How do we do that? I want to change to the whiteboard. So if you have something to write, please do so quickly. Are you there? I want to change to a proper whiteboard. Can I do that?
Yes, sir.
Yes.
Okay. So let me change to the proper whiteboard. We're going to look at an example, and the examples are these. Suppose Y varies directly as the square of X. Suppose Y varies directly as the square of X. When X equal to 2, Y is equal to 20. Find the constant of variation. Find the constant of variation, I. Find the value of Y when X is 5. And then the next one, find the value of find the value of X when Y equals 2,000. All right, so we're going to look at this question. I hope that the background, the foundation is good, and therefore we'll all be able to do it and do it very well. Suppose y varies directly as the square of x. When x is 2, y is equal to 20. We should find the constant of variation. We should find the value of y when x is 5. Also find the value of x when y is 2000. Now, how do you do it? How do we do this? We're going to translate the first sentence into some mathematical expression using symbols. So we're going to write, this is our solution. We're going to write y proportional to x squared. Since y varies directly as the square of x, so y is proportional to x squared. Then we write y is equal to kx squared. We have to indicate where k is a constant of variation. It is always important to define any other variable you choose to introduce. Good. So if k is the constant of variation, how do we find it? We are going to put in the initial conditions. What are the initial conditions? X is equal to 2, y is equal to 20. So we write when x is equal to 2, y is 20. So we're going to write 20 is equal to k2 squared. 20 is equal to k2 squared. And I think that we can easily get the k. Okay, so what is k equal to?
So k is equal to 4.
K is equal to 4.
Ah.
The constant of variation is equal to 4. All right. Now let's continue. I'm going to use the space. Yes.
I think it will be 5.
Okay. Hey, Augustine, are you dozing off?
No, sir. It's 5. Sorry.
It's all right. Okay, so the constant of variation is 5. Now, having got the constant of variation, we are going to rewrite the expression for y in terms of x. In other words, that formula we arrived at with the k, we are going to now rewrite by replacing the k with the value that we have. So we're going to have y equal to 5x squared. Now, we have found a constant of variation. We want to find the value of y when x is 5. So that is simple. When x is equal to 5, what is y? We have 5 squared. And this should be, what is 5 times 5 squared, Lisa? 5 times 5 squared, what is it?
125.
It is what?
125.
Today you are far away from your device. You want to get up again?
No, please.
Okay. So when x is equal to 5, y is 125. Cassandra, we want to do the other one. That's the last question. When x is equal to, when y is equal to 2000. I want to get the value of x. So what do we do? Write 2000 here. This is 5x squared. And I'm sure we can all get the value of x. Is that correct?
Yes, please.
Yes. So you work out what the value of x is and tell me. I'll write it down.
Kofi. X is 20.
X is what?
20.
X is 20. Okay. To the rest of you, is x equal to 20?
Yes, please.
Yes, sir.
Okay, that is fine. Okay, I think we can take some more example. I mean, for direct variation, We don't expect that to be difficult. And because it isn't, we usually will not spend so much time, just a few questions that will let you get a concept, and then we'll move on. Let me go to the next page. Okay. The next page, I have this question. The square of y varies directly with the cube root of x. The square of y varies directly with the cube root of x. Square of y varies directly with the cube root of x. Okay. When x is equal to 1, 2, 5, y is equal to 2. Question 9. Find an expression for y in terms of x. Find an expression for y in terms of x. Find an expression for y in terms of x. Then the next one, find the value of y when x is equal to 6, when x equal to 10, 24. Yes. Find the value of y when x equal to 10, 24. Okay. How many minutes? How many minutes? All right, don't worry. I'll set the time myself. I will set the time myself. Don't worry at all. Okay, so the first one, we should find an expression for y in terms of x. I'm sure you are already there. Augustine, have you got that? And what have you got?
Sir, please. Okay. So the solution.
Mm.
The question is, the square of y varies directly with the cube of x. So
Okay.
then we have the square of y, which is y squared.
Okay, so we have y squared, yes.
Which is directly proportional. That's to x cube.
Hey, cube root.
Cube root, sorry. Cube root.
You know cube root like
Yes,
this.
sir. Yes, sir.
Okay.
And we've given y squared as y to be 2. and the square root of 2 is 4.
No, but there's something else we need to do before we get here. What is that?
Okay, we
We
need
have
to
to
put
change
in
the
the
proportion
constant.
to an equation. You
Yes,
get
sir.
it?
Yes, sir.
Yeah, so we'll write y square is equal to cube root of
Cubic
x.
root x.
And we
Yes,
must
sir.
always say that where k is a constant of proportionality. Where k is a constant of proportionality. Okay, so continue.
So y is giving us 2. So 2 squared is 4.
So we're going to make a substitution. 2 squared is equal to
So
k cube root
cube
of
root of 125.
125. All right, go ahead. So 2 squared is 4, as you said, yes, and then the rest will be
Yes, sir.
yes,
K.
Augustine.
35k.
5k. Okay. So we can get the constant k to be yes.
4 out of 5.
4/5. Good. You have done well. Elisa, it's your turn.
Yes, sir. Okay. So the next question, we are supposed to find the value of y when x is 1024.
We haven't finished with the first part of the question. Do you agree with me?
Yes, please.
So what is
Okay.
left?
We are supposed to write the full
Okay, so
expression.
it will be what?
So y is equal to
Y square
y squared is equal
equal to
to
yes
4/5
4/5 yes
cube root of
x
1
right.
to x. Yes.
Okay, so that is it. Now continue.
Okay, so the next question, we are finding the value of y when x is 1024.
Okay, so when x is 1024, when x is 1024, we have y square equal to 4/5, the cube root of 1024. What's the cube root of 1024?
10.08.
10.08. Aisha?
Yes, please.
Okay. So we have the rest, we can do it. We have y square is equal to 4/5. No, but I think this one, we can use the calculator and do the right answer. We can evaluate all at once. Okay. Do you agree with me? Cassandra, do you agree with me?
Yes, please, Mr. Kofi.
So you work out all of that
This
and
is
give
8.063.
8.
063.
So then what is y? The square root of 8.063. What's the value?
2.84.
2 point what?
84.
2.84. All right. Can we go to the next question?
Yes, sir.
Please.
Okay. So let me go to the next page. The next question reads, y square. Okay, let me write it the way it is. It says the square of y varies with the square of y varies with x plus b. Full stop. Square of y varies with x plus b. when x is equal to 13, y is equal to, where is it? When x is equal to 13, y is equal to 6. And when x is equal to 46 whole number 3/4. I don't know why that number. 46 whole number 3/4. Y is equal to 9. Okay. The question is, find the value, find the value of B and the constant of variation. Find the value of B and the constant of variation. Then I an expression for y in terms of x. An expression for y in terms of x. Then the last question, where is it? An expression for y in terms of x. Then the value of x as I. The value of x when y is equal to 16. The value of x when y is equal to 16. All right.
Mr. Kofi.
Yes.
This is a 46 whole number 3/6.
3/4. But let me
Okay. Thank you.
write it clearly. Okay. Hey, Elisa, so is that where you have got to?
No, please.
Hey, so if you are not there, why do you ask? That is where you are. It's all right. Okay, so let's start. Cassandra. Cassandra, are you there? Cassandra. This girl likes cooking.
Mr. Coffee, I'm here.
Okay. Yes.
Is that just that?
Yes.
Okay. So, like, we'll have a simultaneous question.
Whether you are getting quadratic equation, that is, I said start, Cassandra, start.
Okay, so we have
Yeah.
they said that the square of y varies with x plus b. So we have y squared is proportional, directly proportional to x plus b. Yes. So
you write x plus b, yes. Then what do you do again?
And we introduce the constant of variation k.
Okay, so you have y squared is equal to k x plus b, right?
Yes, please. Then we come back to the question. They said when x is equal to 13, y is 6. So we put it there.
6 square This is K 13 plus B.
Yes, please.
So we have 36 here. This is K 13 plus B. Okay, so let me continue on the right, on the side, yes.
We have 36 is equal to 13K plus KB.
I think we can leave that for now.
Okay, so the second one.
Mm.
Second one, so when X is 46 for number 3 on 4, Y is equal to 9.
So we have
So
9 square. This is K. What is the X? X is 46 whole number 3 over 4 plus B. Okay, I think we can make that one an improper fraction, right? Now 9 square is 81. This is K. 46 whole number 3 over 4 as an improper fraction. What do you get?
187 on 4.
187 on 4 plus B. Let's call this one equation 2, and then what we got here as equation 1. We want to solve 1 and 2 simultaneously. Elisa, what should we do? Elisa, want to solve 1 and 2 simultaneously. What do we do?
You subtract 2 from 1.
No, you don't have to subtract. The way we have written the equations, subtraction will not be the best to do.
So we are not expanding this the other.
Yes, side. Because we have not expanded. Because we have not expanded, we don't need to subtract.
Okay.
So what do we do? We can divide. We can divide. We can divide. So if you divide 2 by 1, you're going to have 81 over 36. Then here you have K. Now 187 over 4 plus B all over K 13 plus B. So that the K will cancel out. Can you say it? Are you there?
Yes, please.
Yeah, so at this point, you now cross multiply, you can do your expansion. I find this approach much simpler than we were talking about. So let me leave you to find the value of K, and then we shall bring in the value of K to get the other one. Good. Hey, did I say find the value of K? No, find the value of B because the K has cancelled out. So find the value of B. Okay, so are you there?
Yes, sir.
Okay.
Sir, to find the value of B, we multiply 2 by cross multiplication.
Yeah, so you do cross multiply. So you do all of that. See, do all of that and give me the value of B. Okay.
Okay. Okay, sir. Okay, sir.
So what is the B equal to?
B is equal to, so should I put it in decimal form or in fraction?
The decimal, is it the terminating decimal?
No, sir.
Okay, then give us a fraction.
I got 631 out of 5.
631/5.
Yes, sir.
But this one will be a terminating decimal.
That's why I get 126.2.
But that's a terminating decimal. It's not a.
I didn't hear.
So
Nah,
one
it's a
what?
terminating
126.2.
6.2.
To the rest of you, is it 126.2? Girls.
Mr. Kofi,
Yes.
please.
Did you get 126.2?
No, please.
No.
Elisa, what did you get?
Mr. Kofi, please. I had 14.
Yeah.
You had 14.
Yes.
Cassandra, what did you also get?
It's also at 14.
Hey, uncle, what happened? The girls are saying the answer is not what you got. Okay. Let's do this. If you cross multiply, you're going to have 81, 13b, no, 13 plus b. And this is 36, 187 on 4 plus b. Now, if you open up the bracket, what is 81 by 13?
It's 81 by 10.
13. What is it?
1053.
1053.
1053
1053.
plus 81b. This one, 36 by 187/4. What do you get there?
36.
Mm-hmm.
Mr. Kofi,
Yes.
please you get 1683.
168 plus 36b. Okay, so we collect light terms. 81b minus 36b. 1683 minus 1053. It doesn't look like, obviously your answer will be correct. So I think the 14 is correct. All right. Now that we have the 14 as the b, we haven't finished. We have to go and get the value of k. So we take one of the equations. 36 is equal to k 13 plus b. 36 is equal to k 13 plus 14. So we have k to be 36/27. What is 36/27? I think it should be 4/3. Is that correct?
Yes, please.
So we have 4/3. Okay, so our equation for y in terms of x. Equation for y in terms of x will be y squared. This is equal to the k, which is 4/3, and then bx plus b, x plus the b is 14. So this is what we have. We should find the value of x when y is 16. Please do that, and let's go to the next item. When y is 16, you have 16 squared. This is 4/3 x plus 14. Complete this and tell me what the value of x is. I'm waiting for that answer.
Mr. Kofi,
Yes.
178.
178. Any confirmation?
Yes, please.
Augustine, did you get 178?
Yes, sir.
Okay. I have another question, but you do that one later, so we can go to the next type of variation, which is the inverse. Okay, so my next question is this. Y plus 1 y plus 1 varies directly as cube root of x. Y plus 1 varies directly as cube root of x. When x is equal to 27, y is equal to 14. Now we should express y in terms of x. Then the next one, we should find the value of y when x is 64. All right, so you find time and answer this question later. Let's go to the next type of variation. Okay, I hope you are finished writing. Let's go to the next page. Can I, Augustine, can I go to the next page?
Yes, please.
Girls, what about you?
Yes, please.
Yes,
But
please.
it looks like our class can actually go a little faster. So in the past, we have made it slow. Is that it? Okay. I like the speed today. So let's see if we can keep up with that speed. We are going to look at inverse or indirect variation. Inverse or indirect variation. In this type of variation, the variables change disproportionately. In this type of variation, the variables change disproportionately. That is, when one variable increases, the other variable decreases. Good. Now, before I continue, let me ask. Okay, let me complete it. Then we can now come to practical situations that illustrate inverse or indirect variation. Okay, if y varies inversely as x, we write y proportional to 1 over x, like this. Or y is equal to k over x, where k is a constant of
Mr.
variation.
Kofi,
Yes.
please, can I excuse myself?
How many times have you gone out of the class? You are going to pay for the number of times you ask for leave. All right, but I hope it will not stay too long. Will you?
No, please, no.
Okay. So the timer has started running.
Okay, thank you.
Okay, so if y varies inversely as x, we write y proportional to 1 over x, or y is equal to k over x, where k is a constant. We are saying that we have two variables, and at this point we know what variables are. Quantities whose values change under different situations. So let's take two quantities whose values change under different situations. That as one of them increases, the other decreases. Cassandra and Augustine, let's look at two practical situations.
Okay, sir.
Or one practical situation where we know two things are related, that as one increases, the other decreases. Yes.
Sir, please, a practical situation is when there are more men at work, the less time taken to do the work. And
That
when
is,
there are less,
if they are not lazying around, if they are not
probably,
lazy about,
yes,
if they are not lazying about, then when you bring
there's
on
less
more
time,
people, it takes
more
a
men.
shorter time. That's good. Okay, let's
Yes.
go to Cassandra. Cassandra is going to say that if you serve a dish and bring more people, the food will finish fast. It cannot be that example you said. Cassandra, let's hear you. Cassandra.
Mr.
Yes.
Kofi.
Yes. Oh, Cassandra. I have, said what you wanted to say. Cassandra, but why are all your examples about food? Okay. Cassandra, let's hear you.
Okay, Mr. Kofi, please.
Yes.
As in practical, as in life,
But that's what I said. Real life.
Okay. So Kofi, please, I think that the okay, so
Cassandra, I don't know.
so
Yes.
Kofi, see if
Yes.
you prepare food. If
Oh,
you prepare,
Cassandra.
so Kofi, I'm giving my example.
So give you an example.
In a household,
Uh-huh.
the number of people in the house
Yes.
determine the amount of food to be
Ah, I said it. That food is what she's going to. It's okay. But one clear example you can add is this. You see, when a baby is born, the baby sleeps for long. But as we age, what happens? The length of time you sleep is less until you go on retirement where you don't have anything to do. Do you get it? Yeah, so within some lifespan, we can say that the length of sleep time is inversely proportional to your age, or your age is inversely proportional to your sleep time. So as you grow, you sleep for shorter time within some age range. Okay. All right. Now, how do we solve these inverse variation problem? They are not difficult. It's just like what we did in the direct variation, except that instead of bringing a direct relationship, it is an inverse relationship. But let's look at this example. Y varies inversely as x. Y varies inversely as x. When x is equal to 2, y is 4. Find an expression Find an expression for y in terms of x. Find an expression for y in terms of x. All right. I hope that this can be answered within some few minutes. Okay, so do that. I have a few more examples to give you. We'll have to be wrapping up so that you can have some time to rest before the last lesson of the day. Okay, Augustine, take us through the solution. Augustine.
Okay, sir.
Yes.
Yes, sir. Sir, please. So the solution, I have y is equal to k over the x.
Okay, but let's start before we get.
Okay.
Let's use the symbol, the proportional symbol, before we bring that proportion. So y is equal to k over x.
And we have y to be 4.
So we're going to have
substituting
4.
The x, which is also 2.
So what's the constant here?
So we have 4 minus.
Hey, is it 4 minus?
Sorry. K is equal to 8. Sorry.
4 times 2. This is 8. So an expression for y in terms of x, what would that be?
4 minus k over a.
Why are you saying 4 minus, my friend? You have k equal to 8. So the expression for y in terms of x will be y equal to 8 over x. You get it?
Yes, sir.
Okay. So let me put example 2 there. Example 2. Y varies inversely as the square root of x. Y varies inversely as the square root of x. Okay. When x is equal to 16, y is 6. Question I, determine the inverse variation equation. Then I find y when x is 4. Then I find x when y is equal to 20. All right. I hope you can finish this under some 3 minutes. So I'm waiting for you. Do that quickly. Let's look at that together and probably bring our lesson to a close. Cassandra, are you there?
Sir,
Yes.
Yes, please.
Yes. I guess go ahead.
I was coming to mention the I.
Charlie, the guy is fast. Why do
Yeah.
you belong to the NSMQ team in your school?
No, please.
But you have to be part, or what do you think? Cassandra, don't you think that she will be a good addition to their team?
Yeah, very
Why you want to
good.
go and present?
Eh. So when you go and join the team.
And how are you going to present for what?
Okay, says you should find the inverse variation relation or equation. You should find y when x is 4, find x when y is 20. Cassandra, where have you got to? Cassandra, where are you?
Mr. Kofi, please, I'm here.
Where have you got to?
Please, I'm also on I.
You also have found which one?
The I.
Okay, so let me do that on the next page. We have y is inversely proportional to, is this a square root of x?
Yes.
So root x. So we're going to have y equal to k over root x. All right. So if y is equal to k over root x, what are the initial conditions? The initial conditions, the value of x and the value of y, those that were given initial.
X is 16 and Y is 6.
So y is 6, x is 16. Okay. So I have 6 is equal to k over 4. So then the k is equal to 4 by 6. That is 24. All right, having found the k, what is the inverse variation equation? Cassandra, you say you had finished that one, so tell us.
So Y is equal to 24 on root
Y
of
is equal
X.
to what?
24 on root of X.
So 24 over root x. All right. Augustine, let's continue.
Sir, please. The second question says we should find when x is 4.
So when x is 4,
Yes.
y is equal to 26 over root 4. So we have y equal to, well, 26 over 2, which is 13. All right, Augustine, continue.
Sir, then you put the y over there.
The third question.
The third
Says
question
find x when y is equal to
is
something. What is
20.
that?
When y is equal to 20.
When y is equal to
20.
20. Okay. So when y is equal to 20, you're going to have 20. This is 26 over root x. Okay. So we have root x is equal to
Mr.
20.
Kofi, please, it's 24.
Sir, 24.
Which one is 24?
The
K.
key.
You are blind. So look at where we started. I have put in 26 and you have not said anything. You see your head. Okay, so if y is 20, the k is 24, then we're going to have y is equal to 24 over, okay, so then y is equal to 12. So here we have 20 is equal to 24 over root x. So root x is going to be 20, no, it's going to be 24 on 20. What is 24 over 20?
That's 6 on 5.
What should
1.2.
be, so root k, root x, no root k. Root x is equal to 1.2. So then what is x? Root of 1.2. I think you get 1.44. Is that correct?
1.095.
You are squaring. You are squaring. You see 1.2 square. So what is 1.2 square?
1.44.
1.44. Any questions? Any questions, please?
Mr. Kofi.
Yes, you are back.
Yes, yes.
You have been away for 35 minutes.
Mr. Kofi, please, can you leave your answers in fraction form or you have to?
If it is a fraction, then it shouldn't be an improper fraction.
Okay.
If it's a fraction, it is not an improper fraction.
Okay. Thank you.
Okay. All right. I think we have done quite some work. Let me see. I have a couple of questions here. Let me see. If I have question on inverse variation, which is a bit challenging. I don't have any. Just a moment. I brought some textbook here. Let me see if I can get one. So you can add to what I gave you when we're changing to the inverse variation. A moment. Okay, I have found one question. Let me give that one to you. It's an application of the inverse variation. And this is how it reads. It takes 6 men. 12 hours. It takes 6 men 12 hours to weed a plot. It takes 6 men 12 hours to weed a plot. Question I, how long would 9 men take to weed their plot? How long would 9 men take to weed the plot if they all work at the same rate? If they all work at the same rate, then I write a law. Write a law connecting, write a lot connecting the time t in hours taken to read the plot and the number of men n. Hence, find t when n is equal to 36. Okay. I think this is a good point to pause. You have some 1 hour rest before the next lesson. 1 hour rest before the next lesson. I may forget, so I beg you when it becomes necessary, especially when it is time for the lesson and I have not opened the class. Just let me know. Augustine, you put some chat there, or I didn't see it. Hello, Augustine.
Yes, sir.
You put some chat there just when I was ready to read. It went off.
Sir, with the I. I had 8.
Oh, you have answered it, eh? All
Yes,
right.
sir.
I said it was going to be.
Oh, okay.
Yes, but it is good you have finished. Tell the girls, don't you see that the guy is fast? So,
Yes.
Augustine, the girls and I are proposing you go and join your school's NSMQ team. Okay.